And welcome once again to another episode of building RC foam model aircraft with section foamed fuselages and hot wire cut wing cores. This is episode number 8 in what you by now are probably thinking is a never-ending list of these things. However, as I said from the very beginning, guys, I'm going through this slowly, and I'm going through it step by step with every single step of the process illustrated. Now, hopefully that's not too boring for you, and hopefully it's helping some of you newbies, because as I also said when this started, this is directed at the totally new builder, someone who's never worked with foam before. But now we're going to go into the last phase of the CAD work, and with that I mean we're going to do the wing with a plan view, and I'm going to show you how to do the templates to make the hot wire foam cutter templates for the wing core. So this video shouldn't be too long. Of course, that's what I've said before, and I lied. But here we go. Stick around. Okay, everyone, we're back in the SketchUp workspace. While I was offline, I completed the formers for all of the XPS fuselage cutouts and sort of parked them over there. I moved our EPS formers over here. This is the ones I'm using for most of this illustration. Next up on the to-do list is to make the templates for the hot wire core or hot wire cut foam wings. And to do that, we need to know, of course, what the dimensions are on our airfoil. There's a tool. I didn't illustrate this, but it's a tool over here on your toolbar that says dimensions. Of course, you click on one point, another point, and drag it up. We'll show that a little bit more later. But at any rate, what we need to do is take this airfoil and make something that we can use to cut a core. And it's going to be very simple and quite a lot like what we did for the fuselage. First of all, we need more or less a rectangle, so we'll just drop that. We'll put it on a line here, of course, that we know is on the ground plane, and I just drop that down there. It's really not important what this size is, as long as it's a good bit larger than your airfoil. Coming down here now, we're going to put some construction lines in to make things easier. And the first one that we're going to do is we're going to decide how far up from the base we're going to have the bottom of the airfoil appear when we sit it down here and have a cutout. Now, this dimension cannot be, I chose 10 because that's just a good all-around distance for me. You want it fairly low because it helps you save foam, but it can't be too low, or the arms from your drop wire cutter will come down here and contact the table on which these are going to rest. So you don't want that either. Next, what we're going to do is move a copy of the airfoil down here. Again, our old familiar M for move, Control C for a copy, and we're going to pick a known point, which is going to be the end point in the airfoil. Now, this construction line down here is a reference line. It's not the be-all and end-all. It doesn't have to be super accurate. This just gives us an idea. We don't want to be below that, and we don't want to be way above it, but just somewhere in the neighborhood. We're not going to drop it on it. There's no need to do that at this point. So if we are there and just come up to clear the 10 millimeter line and put it right there. Now, to make sure that we haven't moved this in three-dimensional space, what I'm going to do is just a quick check. I'm going to take yet another taped tool line and come up here and see if we're on. We know that this bottom line is on the ground plane, so moving one parallel to that will also be on the ground plane. So now we know where this should be, no matter where it ends up being. As long as we drop it back on that line, it's on our ground plane. Now we're going to start doing the dimensions and reducing some of the size of this huge rectangle that we have. What we need is a way to cut both the bottom curvature and the top. So we're going to need two templates, one for the top cut, one for the bottom cut for the root rib, and we're going to need two templates cut, of course, for the smaller dimension over here on the tip rib. And here's how we're going to do that. Right now I'm going to hit explode on this because we're going to continue working on this and removing parts. So if I explode this, this now becomes part of this rectangle that we have just done. And we can draw on it and both will sort of take. Now I'm going to get rid of this kind of declutter thing. I'm going to erase this lower line. We don't need that anymore. As a matter of fact, I'm going to declutter a lot of this stuff up here that we used to measure things. I don't know why I let it just keep building up. It just confuses the issue down the road. Okay, enough housekeeping. Now, there are two things that we need on these that are going to be common to both sets of templates, and that's a lead in and a trail out line. So we'll come up here to the very first point on our airfoil, and that's just a bit below the line as we see here. So we're going to go from that, and the distance that we're going to go is pretty much immaterial as long as it is, we're going to go on the red axis on the face. As long as it's long enough to give us a good lead in with our hot wire, then we'll drop down to the base. Now we're going to cut that down to shorter, but I got to measure it first. So we'll take our good old tape tool and see what we got here. We only need about 20-25 millimeters. It does not have to be huge, and I've got huge, so let's undo that. We'll go to the tape tool, tape it here, and we're going to go out 25 millimeters. And we're going to drop our line down there. Okay. Here we go. Should have done that first. Now we also need, just as we came in with the hot wire here, we need a lead out when the hot wire exits the curve, and we're going to do the same thing. And this time I'll be smart enough to use the tape tool first, and we'll go again 25 millimeters out on, whoops, there we go, 25 millimeters out the back, and we'll take a line. We'll go from point to point, and now what we have done is created a shell here, and we can get rid now of a lot of this extraneous rectangle that we use. We're just going to more or less cut this away. So our erase tool comes into play now. I'm going to hide our construction lines again so that I don't end up inadvertently erasing them. Bring the construction lines back. Okay. Now there's a couple of things that we need to do further. First of all, when the hot wire comes out of the back of the curved cut, the wire is going to keep moving. So back here, anywhere, this is arbitrary, of course, back here somewhere after it exits, and far enough so that the heat from the wire won't damage the cut, we're just going to come back here and drop a little notch. Now the dimensions of this notch are not extremely important. What it does is it acts as a catch. When the wire comes off, it's going to keep moving, it's going to get here and catch, so that your drop bar just doesn't drop on the floor. Alright, well, we've got that. Now that's looking great for our top cut, except for one more item. When we align these templates with the end of the foam blanks that we're going to use to cut this, we need some way to align the front of this with the front of the foam. So we're going to drop a line from the very front of the airfoil template, of course, and then we're going to come in here with another line, and we're going to make a cutout. And again, we'll use our good old tape tool here, and we'll make this about 4 millimeters. What we're doing is we're going to take out a notch on the front of our templates. Now that will allow us to align very easily. All we have to do is lay a straight edge on the foam core and then bump this up against it. This will allow us to align with the front edge and be absolutely true to where we want to start the airfoil. Now, a couple of other things before we make the lower one that we want to do, and we want to do this because this part of the airfoil, this bottom base, has to be exactly the same for the top and the bottom. It can't be repositioned or moved sideways or up and down. And in order to hold these onto the foam block, we're going to need holes in here that I use finishing nails, and I found that 2 millimeters is a good hole size for a finishing nail. Your mileage may vary. Whatever you're going to use to stick these templates to the end of the foam block, use that diameter. Like I said, finishing nails work fine for me. So in order for these to all be on the same line, I'm going to come up here, about 6 millimeters. Again, this is arbitrary. You don't want these holes too close to the edge or too close to your hot wire cut. And now we'll come in here with a circle tool. Just hit C or choose circle from your tool cell here. And we're going to need one in the front, and that's going to be a 1 millimeter radius for a 2 millimeter diameter hole. And then we're going to punch that hole in there. Then we're going to come do an automatic save again. Then we're going to come back near the back of our foam block, not to the very extreme back, and we're going to do the same thing. Again, we're going to do a 1 millimeter radius for a 2 millimeter diameter hole and punch that out and delete it. And then somewhere along the middle, again, not critical, somewhere along here, yet another 1 millimeter radius, 2 millimeter diameter hole. Punch that out. Now we've got the holes set so that we have a means of attaching these templates to our foam core. And since we're going to need one cut for the top, one cut for the bottom, that means 2 templates, and we want these to fit exactly in the same holes. So now we're going to take what we have done so far, and we're going to move a copy. Before we do any other manipulation with that, and just come down on the green axis so that we know we're on the same plane. Now we're going to use this top one for the top cut, and that's fine. We can just leave that as it is, or it doesn't really matter. If having this line in here bothers you, you can always just come in here and erase this bottom part, but what appears here is just going to be cut out, taped on to whatever material that you choose to use for your template material. I'll go ahead and erase that just to Make it pretty. As you can see, these curves are not actually curves, they're line segments. There's just a lot of them and they appear to be curves. Oh, there's even one way down here. Okay. Alright, there you go. That one is done. Now we've got to have our lower curve in here, and we are going to have to do some erasing down here. So right now, we select that template, we get rid of that, and come in here and start getting rid of that upper curve. There we go. Now you have it. One thing I am going to do, just for reference sake, is I'm going to draw another line on the template at the very back where it comes off of the foam. So if I go up here, now we've got a line that will be through, and we'll know if this aligns with the back of the foam block that we're absolutely true in our alignment. It's just a reference line. That line is probably not absolutely necessary. Okay, now we've gotten the root rib template done. This is all we need. We can print this out, stick it on a piece of whatever you're going to use. Like I said, I use masonite cut out with a scroll saw, or some aluminum flashing, whatever you can use that can be smoothed so that the hot wire can run over it. Now we've got another set of templates to make, though, because of course our wing tapers. So we're going to have to come over here and measure what we're going to need for the tip template. Now we're going to make this template start right about here instead of out here at W9, because we need to have the foam block, the square portion of the foam block, end before we start the tip curvature. The wing tip is going to be a separate block of foam that's glued on after we've cut the core. We'll glue on a separate block and then shape it to match. So if we come over here now and we start looking for a place to drop a line, we should see that the curve starts right about there and come down to here. Now, again, I'll drop another line up here so we'll have some place to reference for a measurement and come out. So we know that our tip rib is going to be, and tip templates, is going to be this long. So now I'll go back to the tape measure tool again to figure out what this length is, and we'll just come in here, get on this line, come down here, and as you can see right there, we're at about 126 millimeter, 125.8, we'll call it 126. So our tip template is going to have to be 126 millimeters long. What we've got to do now is take our master component, move, Control C, a copy, and we're going to move this over and resize it. I'll drop it down here. Now, we have to be careful when you're working with components in SketchUp and you're working on a copy of the component. Whatever I do to this will automatically be done to that. And we don't want that. We want this to remain its full size. So what you can do, there are a couple things you can do. Number one, we could explode this now, but I don't do that. I want to size it first. Number two is you can right click, and instead of edit component, we'll just make it unique so that what we do to this component will not be mirrored over here on this one. So now this is a unique component. So we need that component, we need this to be 126 millimeters long. And to do that, again, just using reference points on stuff you've already drawn is about the easiest way to get lines parallel. Let's go up here to this leading edge. Well, I'll tell you, I'm just going to drop this somewhere. There we go. Now we've got a vertical. Now let's take that vertical and go 126 millimeters that way. Okay, there's how wide we need our tip rib to be. So come up here, select this, hit S for scale, or come over there and select scale from the toolbar. Now we'll start pulling. Again, we pull all the way across on the opposing handles so that we scale the entire plane. We're going to pull that in there to that guideline, and that in there to that guideline. And now we've got 126 millimeter airfoil. So if we come down here now, we're going to do the exact same thing except on a smaller scale. Let's put a rectangle down here, again, more or less arbitrary size. We're going to return over here because we want the wing to be straight, of course. We want the center line of the tip airfoil to be on the same center line that the root is on. So in order to do that, we'll come over here, come up to the exit point, and that shows us where the chord line is, and we want this to be on that chord line. So now we'll take it, we'll select the component, and we're going to move it. Well, looking at it now, the component here is just a little bit larger. I mean, it's not very much, but I tell you, I'm not going to move that, and here's the reason why. When we're cutting these cores, the hot wire out at the tip is going to be moving a little bit slower than the hot wire at the root. And what that tends to do is it tends to melt back the foam a little bit. It tends to make your tip distances a little bit shorter than they actually should be. So I'm going to leave this just very, very minute amount of overlap here. I'm just going to leave that there. That will work just fine. So let's go in here and move this. We'll take this tip and we're going to come down here and put it on the chord line intersection right here. Put it on that line. All right. Now that we have that line in there, we're going to come in here and start erasing all the extraneous stuff on the back, just like we did over here. Now we want these to sit the same distance off of the table, so we'll come over here to this end point and we'll just take a line measured from that point and put it right across there. As you can see, if you hover over a point in SketchUp, it references that point for other lines that you might want to draw. So it referenced that baseline for us just fine. So now we've got the bottom of the template. And we'll come over here and get rid of that. So the bottom of the template's done. Now we're going to do the top the exact same way. Come in here, 25 millimeters. Come back here, tape tool again. Another autosave. Another 25 millimeters here. There we go. And now we're going to do the same thing that we did here. So I'm going to speed this up. You don't need to see this twice. So I'll speed this up to save time. And there we have it. There are the template cutouts that we're going to need to make. And again, you can use any material that works for you. If you're a newbie at it, Formica is hard to beat. You can use G10 resin impregnated board or something of that nature, but this needs to be cut out accurately and smoothly, and it has to have a smooth surface for the wire to run over. Back again in the SketchUp workspace. However, I want to take a quick moment to insert another clip here showing the materials used, or that I use, to cut these templates that we've just been working on. Here goes. Okay guys, here are some examples of airfoil templates that I've got in my my template stash. I've got scores of them now, but at any rate, these are some used on past models, and I just wanted to show that your templates can be made of various materials. I now have a 3D printer, so I even tried 3D printing some airfoils. Now, of course, the plastic that this is made from is not heat resistant, so what I had to do was take some aluminum duct tape and put a little duct tape cap on that to protect it from the wire heat. But 3D printing works fine if you've got a 3D printer. Next is very common stuff found every hardware store. It's aluminum flashing, and these were cut from aluminum flashing using a scissors, and then the roughness sanded away. These here, they still have the paper stuck to them, but these are Formica, and you can get actually you can go to Home Depot and Lowe's and get free samples. Just go to the cabinetry or kitchen section and they'll give you free samples of this stuff. Or if you have some sort of a source, it's just thin Formica, and it perhaps of all of these works the best, but they all work. So choose whatever material that's best suited for you and use that. Well guys, another one went longer than anticipated, but that seems to be the way these things are going. Next episode, number 9, is going to be devoted mostly to how to print out what we have already drawn. All of the items have to be printed out and somehow gotten onto tag board, it's called tag board, poster board, whatever your supplier calls it. We've got to get the templates on that so that we can use it to guide the wires. Now, that's going to be pretty easy for those of you that are using CAD programs that are other than SketchUp. However, for us SketchUp users, getting those printed out is a convoluted mess, and that's just because of the way SketchUp is designed. Their paid program has a companion program with it called Layout, and it makes it very easy to print stuff. The free version, though, sort of makes you jump through hoops to do it, but the hoops aren't all that far off the ground. So I'll show you how to get that done in the free SketchUp Make program, and all that's coming up in the next episode, episode number 9. Thank you.